Let's take a closer look at the REST API in a simple yet detailed way. In the last video on the subject of APIs, we learned that the API is, you talk this way, then I do this. When two softwares exchange requests and responses, it's about how one side should send the request, from the other side how to respond. An API is like a menu that sets this in advance. If you haven't seen that video, you can see the link in the pinned comment. Well, let's explore the topic of this video, the REST API, or more accurately known as the RESTful API. REST API is one of the various types of APIs that is most widely used today. If API is a promise that, when A requests this way, B responds this way, a RESTful API is one of the various formats that specify how A requests and how B responds.
So if it's popular, there must be a reason for it, right?
Yes. Let's take a direct look at examples of RESTful APIs and find out why this is a good API format. There's a private library called YalcoBooks. The librarian in this library manages the information and loan status of the books using a tablet. The tablet has a book management app installed on it. This app communicates with the server where the book information is stored using a RESTful style API. What they do can be largely divided into 4 categories: create, read, update, and delete. Actually, this is not the official definition of RESTful API, but it's a widely known and used concept, so I'll explain it. First, create is literally putting in new information. In terms of the library, it's entering information of a new book. Read refers to querying, for example, getting and reading a list of books or information on a specific book. Update is changing the information of a specific existing book. Lastly, delete. You can easily guess it's deleting the information of a book. Not just this library app, but most of the services we use are made up of these 4 tasks through the API. When these 4 tasks are written as RESTful requests, they look like this. Each one is for adding new book information, retrieving the list of books, checking the information of the book with index number 1, editing the information of the book with index number 20, changing the rental status of the book with index number 7, and lastly, deleting the book with index number 123. Each of these belongs to one of create, read, update, delete. First, we can see that we are using the HTTP protocol and sending requests to such a URI. HTTP is not a requirement of RESTful API, but because it is easy to implement the conditions of the RESTful API, HTTP is mainly used in the field. Now let's take a look at these URIs. This is not essential either, but it is clearly indicating that it is being used as some kind of API. This virtual domain is the server address, and this API can also be changed, so we attach version information like this. Then, it's specified what data each request is about. Because we handle data about books, you can see that it is specified as books, the plural form of book.
But there's no indication of what this request does on this address. Adding information and viewing the list have the same URI, and individual viewing, modifying, and deleting are only marked as books, so there's no distinction between these addresses because it's not indicated what it does.
Yes, it's an important principle of RESTful API. First, this URI must express what resource this request is about, and should only express it as much as possible. Through this part, we can know these requests are about books in the library. If it's a request about a specific book among books, it's specified by adding an index number at the end, which does not overlap with other books like this. Verbs that indicate what to do, like add, modify, delete, should preferably not be included in the URI. The type of action to take is expressed by this HTTP method.
Post, get, put. I've seen these a lot when coding. What are these?
I will make a video later that explains HTTP in detail, but in this video, I will explain it simply with an analogy. There is a postal service called HTTP. There are several types of mail or methods that can be sent through this postal service. Let's only look at those used in RESTful APIs. Get and delete are sent in an envelope, and post, put, patch are sent in a parcel box. Post, put, patch can contain more information than get, delete. These two envelopes can contain the same things and amount, but the colors of the envelopes are different. These parcel boxes too can technically contain the same things, but the colors of the boxes are different.
So, you're saying the color represents the characteristics or purpose of the mail.
Exactly, that's right. Think of each request as being sent in a colored envelope or parcel box. This signifies what type of operation is being requested on the resource.
So, once I know these, I can immediately understand what and how is being requested just by looking at this request, right?
That's the really important part. This method and URI of the request itself clearly indicate its purpose. Developers can easily learn how to use a new API without much difficulty when collaborating with other teams or using a public API for the first time. That is, if the API was well made, following these REST principles. Let's take a closer look at each one. We're going to start with the read requests here. Because these requests are asking for something to be shown, there's no need to send a lot of information. So, they are sent in the GET method, which we likened to a letter envelope. First, a request to view a list of books. Books, the plural form of the book, is attached to the place where resources are specified. And several books information comes in as a response like this. JSON, which allows for structured data representation and is lightweight, is often used in RESTful API requests and responses. In this example, only 3 books are shown as a result, but in reality, there would be a lot more. If you want to filter under certain conditions, you can use query parameters like this. This way, you can check out the books that are in the available status, that is, available for rent. Even without any filtering conditions, simply sending it in this way would bring in all books info from the database. So, in real-world instances, page information is attached like this. This means, please send the data from the first page with 10 books per page. This way, it doesn't cause overload, right? The next one is a request to receive information about a specific book. You just need to attach the unique identifier for the item at the end, like this. In order for this to be possible, you must design it in a way that each item has a unique value when you build the database. Another principle recommended in RESTful API is HATWAS. It includes information about other available requests in the response of each request. It's like saying, you can request these functions this way about this resource.
Like when you order pasta, they give you the pasta and also give you a coffee and dessert menu.
That's a suitable analogy. Through these link informations, developers can take a look at what requests they can send next without having to go through all the API docs. Even if the details of this part of the API change, making the client reference this information means there's no need to change the client's code. Although I will omit it because the code is long. Remember, it's good to apply this HATWAS to the responses of the requests we will cover in the future. Each resource can have its parent or child resources. In the case of a book, it can have reviews as child resources. So, if you want to see the reviews for the book with an index of 1, you can compose the URI like this. Through this, not only the information each request wants to get as a response, but also how resources are related to each other can be easily understood from the URI. Now, let's look at the post request, which corresponds to create. If you want to input the information of a new item, you'll need a box, as the information can be very large, right? That's why we use a post request. With the registration of a new book, you just need to specify which resource the request is adding data to. In parcel-like requests such as post, put, and patch, there is a space called body, where you can load large capacity data. Then, you put the information of the book to be registered in there. After the book is registered successfully, the server gives back the newly added information like this. You can see that information, like the index number, which is automatically given when an item is added, is also caught. Through this, the client can immediately check the information of the book just registered using the GET method. Just to remind you, this is an example where HATWAS is omitted in the response. Next is the update, the process of modification. The difference between put and patch is whether to completely replace all or partially modify. As I mentioned, the size of the parcel is the same, but the purpose is marked differently in color. Modification is about a specific item, so you attach an identifier stating which book it is. A put request is used to replace the entire information of a specific item. So you put all the information to be filled in there into the body like this. The result can send back the success of the execution of the request like this, or it can also send back the modified result as a whole. On the other hand, if you only need to change some of these, you don't have to do this heavy work. In such cases, you can simply use patch to send the part to be modified. The response can send back the execution result. If you send this content via put, the values not included here will all become null theoretically. As I mentioned, put is about tearing down and replacing. Lastly, it's the delete work. All you need to do for this request is to specify the book to be deleted, so an envelope would be enough. So, you can use the delete method like this. Write the identifier of the book to be deleted in the URI and send it. For the result, you can only send back the success of the operation.
Now that I've learned it, it's not that difficult.
That's why it's widely used, because it's clear and intuitive. Now, I'll tell you about other important parts of the RESTful API that I couldn't mention in the previous examples. First, the status codes of the responses. Just like the mails we receive have stamps or stickers on them, the response from a server also contains a status code that provides the outcome of the client's request. All the examples I showed you before are instances where the request was successfully processed. In such cases, the server responds with a 200 series status code. On the other hand, when there's a problem with the client's request and it's not successfully processed, we have a 400 series code returned. This is the case when the URI is incorrect, or when the client makes a request outside of their permissions. However, if an error occurs due to a server-side issue, then a 500 series code will be returned. Such status codes are essential to clearly represent how each request has been processed. Another characteristic of the RESTful API is stateless communication. It means that the server should not store any state information of the client. Simply put, the server should not remember anything about the client. Therefore, no matter how many times a request is repeated by the client, it must include everything it needs.
So, it's not okay to say, hey, could you tell me that thing I asked earlier again, right?
Yes. This is indirectly linked with the next feature, idempotence, which means that no matter how many times the client sends the same request, the same response should always come back. Except, of course, when the actual data has changed.
So, no matter how many times the client asks the same question, the server can say, didn't I already answer that for you several times, right?
For now, you can think of it that way. Clients and servers should not remember each other. However, it is good to remember what responses they sent and received. This practice of saving data once obtained for use again is called caching. If the client caches the response to a request, it does not need to send the request every time the same data is needed. And if the server remembers what it responded to a particular request, it does not need to extract information from the database again when another client sends the same request. It can simply send what it already has.
Since each request in a RESTful API is distinctive, it would be easy to cache each of them.
Yes, that's right. In this way, I have explained the essentials you need to know about REST API. In the next videos, we will look into other API formats such as SOAP and GraphQL. See you in the next video.